Uh, Good afternoon, everybody. My name is Ram Podal, and actually, I was planning to talk about the making of thermodynamics too, and like what goes behind the scene kind of thing. But as I was not able to work on that this morning, therefore I decided to go for this talk, the evolution of cooperative behavior in human. Actually, this is the title of my talk for this conference, and the question for this talk, Kevin, can you listen to me?
Ram, is your video camera turned on?
Oh, it's not. Sorry. Can you see me now?
Yes.
Great. And this is the title of my talk, Evolution of Cooperative Behavior in Human. And I borrowed this title from the Science Journal back in 2005 on its 125th anniversary. The editorial team of the Science decided to come up with the 125 question challenging science. And as they were doing it, that was a little unmanageable, and they come up with the 25 big questions along with 100 smaller one. And one of the 25 big questions is, how did cooperative behavior evolve? And I'm gonna talk about one of the class of that question, and my focus will be especially on the human and the human society. And when I have to talk among the genius audience like this, the first thing I would like to do is go to the answer directly. And in order to address the question regarding the evolution, I argue that the Newton's third law needs to be generalized to take physics from non-living to living being. Actually, the fundamental forces in physics, these forces are inadequate to take physics from living being to non-living to living. That's one of my arguments I'm going to try to convince today. The second one, I'll do that using a new form of energy defined through a new theory called social field theory. And with that theory, I'm going to define the Hamiltonian in the social field, and I use that Hamiltonian to come up with the equation of motion for a social system that Wolfgang Wildis from Stuttgart has long been waiting for. And that will be my proposed equation of motion for a social system. Let me start with the field theory, general concept behind the field theory at the very basic level. On the screen on the left, you see Earth and apple. The apple is in the gravitational field of the Earth. And by the virtue of this configuration, the apple has some potential energy. As you see in this equation, V is equals to GMM by R. This is the potential energy of an apple in the gravitational field. And the potential energy for the Earth will be the same. But let's ponder about that. What happens if we take that apple to moon? If we take that apple to moon, nothing changes with the apple, just it moves to the different gravitational field. By virtue of that movement, now the apple has entirely different value of its potential energy, I think this example is also true for a human society. Actually, for example, suppose I'm from Nepal and I belong to a society in Nepal. Just because I'm in Nepal, I may have a different potential energy compared to when I came to America. That's the kind of argument I'm gonna make. And what I argue is that the field theory that was propounded for the non-living beings can also be extended to the living system like human society. That's my argument for the field theory, or the rationale behind the field theory. And let's go into a little further detail. And let's make this apple living for a time being. What do you think this apple will do? Suppose the apple is living and the apple know about the energy state of its cell, then probably what the apple would do is try to go to the higher energy state. And the apple can go to the higher energy state by different means, either by increasing the mass of the earth or by attaching some mass of the earth on itself, or different relationship, or moving forward or backward, depends upon how you define a negative or positive. Therefore, there are multiple ways the apple can increase its potential energy. And I argue that this kind of situation is also true for the living being. And next, I'm going to talk about the Newton's third law. This is the basic statement of the Newton's third law, as many of we know. And this Newton's third law is biggest obstacle for physics to go from living to non-living. And the reason is because for living being, there is a power dynamics involved. And to generalize this Newton's law, I formulate the Newton's law, or I try to generalize the Newton's law as you see here. F12 is equals to some scale factor, some time lag, and basically what I'm going to say here is the living being has capability to react differently. They can amplify the reaction or also minimize the reaction. And they have a memory, therefore they can lead or lag the reaction, which is not in physics so far. And I would like to explain this concept further with the concept we call object egotism in biology. Basically, that's the alternative statement of the Newton's third law. That's what it says is object responds only to the influences acting upon them at the instant that those influence act. Non-living object may have that characteristics, but living being has capability to scale those reactions, as well as because of the memory, they can delay or forward the reaction. And non-living beings has reciprocal interaction, like Rij equals to Rji, but that's not true for the living being. Living being can go beyond the non-reciprocal reaction, as I have explained earlier. And moreover, living being also have ability to go up the ladder by utilizing the internal forces. They don't need external forces to move up the energy ladder or go to the higher energy state. That's the kind of basic outline I have made for the living and non-living. And this idea of connecting dots between living and non-living is not new. And this has been on the, for a very long time, it's a different form. And these are some of the names came to my mind, made a good contribution on that arena. And I owe a lot to them. And in my opinion, in order to connect natural science and social science, there are many languages, as you see on the left. But my focus of talk today will be based upon energy, and I call that energetics. And the energetics concept arises in natural science. It has defined various kinds of energy in natural science, but that's not true for the social science. Therefore, what I thought, probably let's expand the energetics umbrella little more so that we can occupy social science. And as C.P. Snow has said that any law of nature would not know the two culture we have created. Natural science and social science is the two culture human has created. And any law of nature, a true law of nature, would not know this difference. And that resonates with Anthony Leggett, his Nobel laureate in 2003, I guess. And according to him, there are three classes of problems in science. And these are the three different classes. A class of problem has a Hamiltonian known and tractable. But to me, the social science looks to me a problem for which the Hamiltonian is probably not known or partially known. On that basis, I'm going to propose Hamiltonian for a social field or like social science. For those who don't know the like Hamiltonian concept, Hamiltonian for the gravitational field will depend upon the mass of Earth, mass of Apple, and the relationship between mass and these two masses. And just to look at the field theory in the further detail, the field theory has unique formalism between various fields. If you look at the gravitational field, electrostatic field, or even magnetic field, they have a general relation, like force has K multiplied by xy by r square, potential is this much. And I argue that this relation is true for the social field as well. And in order to define social field, we have to characterize the society variable. This has been done by a professor in MIT back in, I think, 1958. His name is Paul Lagerfeld. He defines society variable by three names: global properties, analytical properties, and structural properties. And these are their definition. Global property is based upon the information of the individual members and society. Analytical property only depends upon the individual member. And the structural property defines the relationship between these two. And I simply map those variables. I call global properties as a social strength, analytical properties as an individual strength, and the structural properties as a social distance. Social distance now become popular because of this pandemic, but this is not a new term. These terms exist for a while in social science literature. And Wright defines this social distance is a relationship of social entities to other, measuring degree of their contact and isolation. And based upon the social field and the variable I have defined earlier, I can define the potential energy in the social field, force, and the total energy, which is sum of the kinetic energy and potential energy. I borrow the hypothesis of the social field from Bohr's theory of hydrogen atom, which says the energy levels are quantized. But unlike the Bohr's theory of hydrogen atom, the social field is quasi-conservative field. That means the energy is a monotonic function of time. And in the social field, I call potential energy as capability, and kinetic energy is capital, and Hamiltonian is function of these two energy, capital, capability, and time. Once we have a Hamiltonian, we can go to define the equation of motion. For equation of motion, we need to have a measurement space. Many of us know that for non-living, the measurement space is a space-time. It can be depicted in many forms. But for living system, the measurement system I defined is based upon the kinetic energy and the potential energy. That is capital and capabilities. And as I have discussed earlier, non-living being makes a non-reciprocal interaction. Therefore, these internal forces, they do not cancel each other. As a result of that, the net force there will be a net force, and also there's some momentum depending upon how those forces are organized. And this is a measurement space. That's basically the statement I said earlier. And because these internal forces are not canceling each other, this resultant system has a net resultant force, and that net resultant force guides the evolution. That's the basic proposition I make here. And based upon that, I'm gonna develop the equation of motion or equation of evolution of a corporation. And these are based upon the social field theory following the general thermodynamics concept. We can define various potential, and the various potential I defined as this as a function of a Hamiltonian, and I call them economic temperature, entropy strength, and the economic potential. And I think that this potential can inform like general parameter like human development index, energy development index, and etc. Now let's move to the equation of motion. Actually, it was Wolfram Uldis from University of Stuttgart, who mentioned that there is no equation of motion for the social system. And I shared that with one of our keynote speaker, and he was not very happy because he used to claim that he has the equation of motion for social system, but unfortunately, Ping O could not make it to the conference. But let's forget that and go back to the equation of motion. The equation of motion for a society, which is an open system, I define that equation based upon the governing equation of the open system, which is rate of change of energy equals to power. Just to back up, this equation conforms with the Bertrand Russell. According to him, the fundamental concept in social science is power. You have to take power dynamics into account. The regular physics will never be able to handle that kind of thing. And social field is hierarchical. And you have to take into account cooperation and the competition when you think about the equation of motion in the social field. Actually, I take that statement from this book. And this is slide again I showed earlier. I think I described it earlier, therefore I'll skip this slide. And these are some properties of the social field. Monotonic. Social field is inertial frame. It is non-reciprocal interaction. Because of this, the internal forces do not cancel each other. It evolves with time, and energy is hierarchical in social field, and it is autonomous. We don't need the external force to evolve over time. It is an autonomous system. And let's go to the equation of motion. Our equation of motion is based upon the equation, general equation for open system, rate of change of energy equals to power. And let's go to the other one. Probably that will be more convincing. Whatever you see on the screen, the left-hand side is simply rate of change of energy. I'm dividing energy by time and taking a total derivative of that. Here, Hamiltonian is function of capital and capabilities. That is kinetic energy and potential energy in the social field. The right-hand side is power. And power is defined as a force multiplied by velocity. Whatever you see here is a velocity term, 1 by tau squared d tau by dt. And the force I divide into the intrinsic force and the extrinsic force. And you can make equivalent to surface force or body force in Navier-Stokes equation. And here Q dot is a source term, and it also includes the dissipative term and sink and other general term. And this is the equation, and this one is a local derivative, convective derivative, and the forcing term. This kind of equation can be used to explain or get inferences about the various like business cycle and various kind of trend we see in the social dynamics. But I'll not go into that deep into this short lecture. And there are papers available who are interested. And this is equation of motion for individual, and for society. You just need to make an ensemble and do something similar to what we do in the statistical physics. And this is an aggregate of Hamiltonian for a society. If there are n number of individuals in society, and just to make it simple, I normalize it here, and the equation for the society would look like this one. This is nothing but the Fokker-Planck equation. And I take a special case for which the I made some assumption, and I took a special case for which the Hamiltonian may look like this. And under certain circumstances or under certain assumption, this equation for the society can be reduced down to the Lotka-Volterra equation. I'm not going to talk into detail for that, but it's just very straight, simple mathematics. Just you need to use the Green's theorem, that's all. And I'll not bring Pierre Bourdieu here. It's not the title of my talk today. You may be wondering about how you're gonna relate to it to the society or like economics. Actually, this is slides probably give some idea like how we can relate this social field concept with the economics. Social field is a physical concept based upon the energetics, and I bet that economics is an abstracted layer based upon this social energy, which talks this concept in terms of value, utility, price, production, etc. Social field is based upon the language of energy, whereas economics is just a language of talks in terms of money. Therefore, this is kind of relation or the abstraction between social field and the economics, I think so. And with that social field in mind, and there I'm gonna just show some implication for economics. This is very general. The social field concept defines capital and capabilities very clearly in the quantitative terms, which does not exist in the economics literature. Business cycles are simply interplay between capital and capabilities and the external forces, surface and the body forces. And poverty is simply the energy state of the individual of the society. Let's not go into the further detail. Those interested can look at my paper. And here is a proposal for physics. Just as you may guess that social field is just an idea for now. Even I would not say it's a half-baked idea. I'm just curious, I just want to throw among the physicists in the room, is this concept plausible or it's simply another fantasy? If it's plausible, probably we have to find some, do some Cavendish experiment, like find out the gravitational constant kind of thing for the social field. And with that, probably we can measure the capability of an individual, and that field concept will also provide some clue about the what is money. Let's not talk about that more. And personally to me, thermodynamics too, which is a platform to connect natural science and social science, I could not find any better cartoon to represent the current state of thermodynamics other than this big elephant and the blind man. I just let you guys in this picture, like who is Adrian Bejan, who is Otto Anila, or who is Dilip. But looks like to me, we are looking at the different sides of the things. We are not telling something wrong, but just it needs to unified into the common framework, and just we have to look at the big picture. And I can already see these different dots in the various talks I have been attending during this last 2 days. This definition I brought from Klaus Jaffe. I hope that he's in the room. And according to him, the process of fusing individual consciousness with the social consciousness has already begun, but it is far from complete. Modern society and the scientific community are developing new institutions as their consciousness rises to solidify their process. And I think that's where the thermodynamics too fits in. And with that, I conclude my talk, and I'll be happy to take any questions. Thank you so much.
How do you ask a question?
Just unmute yourself and ask question directly.
Okay, this is Charlie Hall. Hi, Ram.
Great to see you, Charlie.
I think that there is something to what you're saying, but in today's environment, in history in general, so much of human interaction has been shaped by prejudice on stupid things. And if your theory could in some way explain this, then I would find that very interesting. And I don't quite understand how it is. In other words, in this, whatever the social field is, depending on people's prejudices, positive and negative, and however, the strengths of interactions are very different between different individuals. There may be two individuals of the same mass, but different skin color or ethnicity or whatever, and the interactions are completely different.
That's completely true.
I was reading this morning a review of a book by Johnson about St. Louis, and he made the proposition that was just new to me, that the capitalists of St. Louis exploited both the white and the black working classes by keeping them at each other's throats. So how could you take a complex social situation like that and explain it in any way with your field theory?
Let me try to answer that. To be frank with you, I don't have an answer for that question, but I'll give you some insight there. Unlike any other field you are talking about, like mass, magnetic field, charge, electric field, social field is a multi-dimensional field. How many dimensions matters to an individual, it's up to him, it's not general. Therefore, we are talking about the combination of fields here. And it's an individual, a living being, an individual is aware of its energy states. And depending upon his awareness of its energy states and its relation to its environment, this different kind of prejudices arises, because the human has tendency to go to the higher energy state, at the same time have ability to, based upon memory or time lag, whatever you say, they can delay the action. The action won't be same for two people, even though they share lots of this dimension common. Therefore, that kind of things you are talking is included in this theory implicitly. I would not say explicitly, but if you consider social field is multidimensional, that things automatically pop up, Charlie. Next, please.
Thank you. Ram, this is Shyam Sundar. Can I ask, make a comment?
Please.
As we know that analogical reasoning has been a great way of learning and developing our thinking about any phenomena in any field, any discipline. And the use of analogies from physical sciences, physics especially, in social sciences, has been of great value, at least for the past century and a half. And the question I have is it the expectation here that we can, at some point of time, create, use physics to explain individual and social human phenomena, or use the physics models from thermodynamics and elsewhere as analogical models with the understanding that they may help us understand some parts of social and individual behavior, human behavior, but not all of it. And if the latter is the case, then is there a sense that there's a place, there's a distance that analogies will take us, but they won't take us all the way? That's
completely true. And actually, my viewpoint on this is like, no way physics can occupy domain of biology. Physics may provide some analogies, some insight, one or other, but these are the two different fields. And even though we assume that maybe there is not a clear demarcation between living and non-living, there is a lot of learning that can be that can go back and forth between physics and biology to inform each other. I'm not saying physics will overlap with the domain of biology or the biology will take over physics, but what I'm saying here is there is a lot of opportunity to learn from each other. Physics advanced a lot based upon the learning from the non-living things, but there is a lot of things physicists need to know about the biology before they can claim some parts of that domain. Personally, I would think that there are lots of things the physicists can learn from biology rather than biology can learn from physics. But that's very much my personal opinion.
I have a question for you from Bill Lawless.
Please.
The challenge facing civilization today is that if we're going to be introducing machines into social life and have things like human machine teams working together, we've got to be able to understand human behavior much better than we have in the past. We've got to be able to make predictions on how humans and machines can work together. Otherwise, we won't be able to design them. It'll be a hit or miss proposition.
I do completely agree with that point. And with that motive, we are trying to kind of get a little better sense of the human. I'm pretty sure that a simple equation will never capture a human behavior. It's a very complex entity and like whatever mathematics. But there is some learning we may be able to get from a physics or other subject general, and that's the idea. And definitely, yes, to understand the link between man and machine, we first need to know both sides, and then only we can understand the interaction better, Bill.
Well, I think one of the things that you can begin to do is make predictions.
Yeah, actually, like when you have an equation, there is always a way to make a prediction. And actually like a business cycle or a kind of like people's tendency to cooperate and compete, these are all the predictions that the social field theory can make.
Well, when you make predictions, you're gonna make mistakes. And some of them will be terrible mistakes, but you have to do that. Otherwise, you can't really learn.
Mm-hmm. That's I completely agree with you, Bill.
If this is Shyam Sundar again,
Please.
Are there any other questions? If not, I'll say something more.
Uh-huh.
Is that okay?
Yeah.
This is Kerry. I'll ask a question.
Please, Kerry.
Hi, Ron. So good job helping organize. I've kind of thought about this in sort of predictions, whether they're whatever theory or equation someone's using, sort of short-term predictions versus long-term predictions, and perhaps in the way that Steve Keen sort of proposed this morning, say the limits to growth model is making long-term predictions, if you will, thinking out a few decades and the general trends, wasn't thinking about what happens in the next seconds or minutes or 1 or 2 years, which is more like what Gene Stanley and sort of econophysics focuses on. And the more I think about it, you know, people gravitating more towards predictions that can occur on short timescales without regard whether they're accurate, the model is accurate on longer timescales. And so this may fall into Karsten Hermann's Palace, or the sort of maximum power principle. If you're going to pursue the maximum power principle, if this is a thing, which I think it is, then, you know, long-term maybe is just not a thing to focus on from the evolutionary biological perspective. So I don't know. What are anyone's thoughts on that? Ram, yours? Short-term, long-term.
Yeah, actually, like
I would like to comment on that question so that you answer it 2 in 1.
Please, Jeff.
There is an equation developed by evolutionary behavioral biologists which explains the questions you posed at the beginning. So it would be nice to use your equation and compare it to the one which does explain in biological and evolutionary terms the questions you pose. And that would build a bridge between physics and biology. I mean, if you want to explain complex things just by physics, it's not possible. If you want to understand the working of a car and you just focus on the physical interactions of the atoms of the car, you won't never get to a meaningful conclusion.
Yeah, definitely.
There are levels of complexity. And in order to understand human societies, you have to understand sociology, biology, anthropology. And your equation should take this knowledge we have built up for centuries into account and not just start from basic physics. You have to incorporate other elements there.
That's
so I would
definitely.
recommend you the extended fitness equation.
Yeah, let me try. And I completely agree. Let me try to carry his question first. But if I understand correctly, it's question about the like short-term versus long-term prediction. As a human being, I portrayed in the social field theory as a I would not say object, or as an individual who know aware about its energy state in the social field. That individual has ability to transform that energy state based upon its awareness about the environment. Therefore, based upon the environment, the individual can act instantly. Therefore, any prediction type of equation would not be accurate to the longer time scale. Because as an individual, that individual can respond to the environment, that responds to the interaction with the other individual. Therefore, making a long-term prediction is very unlikely. But still, we can make some probabilistic information or probabilistic inference from that, Carrie. That's my answer for that question, Carrie.
Ram? Ram?
If I may,
Please.
Oh. This is Charlie. I liked your talk most when you're talking about power, because clearly people have power over other people. And we need to think about why that is and how we might want to modify that. But a question for you is, if there is a field between people and you don't have some kind of a meter to measure it, and you can't measure what this is, where are you? How have we advanced it? If the concept of people having power over each other is true as some kind of a field, as you suggest, but we can't measure it, so what?
Actually, the measurement parameter, Charlie, will be the trust level or whatever describes the interaction between the two people we are thinking about. But I completely agree that the measurement is a problem unless we can measure properly. Then we cannot quantify that power and make other kind of interpretation out of that. But
we can socially, if you're my student, I have power over you because you have to do what I say or I won't sign your dissertation. Mm-hmm. That's power, and it's measurable in a certain way. But how you do this more general, I mean, so you can measure power, but you can't measure it with some field meter.
I completely understand your question, but Charlie, I don't have a clear answer for that. Therefore, I would like to put that off for a later discussion, but that's really a great input for me, Charlie. And I think I would like to stop here. And actually, I was trying to show this audience a video about the evolution, and I'm gonna try to play that next. And let's see. We have like 4 minutes. The video is just for 4 minutes. Therefore, I think we still have that time. Please bear with me. I'm going to share the next screen. That video is about the common state of knowledge about the human evolution. Let me share that. Can you see something, Christine?
Yes.
In origins, even though my training is in the law and in history, it has
ever been an avocation of mine to contemplate and to study the origins of man and of life here on earth. And many theories of origins have been propounded throughout our nation's history. 1859, a sincere biologist returned from the Galapagos Islands and wrote a book entitled The Origins of Species, in which Charles Darwin, offered a theory of the origin of species, which we've come to know as evolution. Charles Darwin never thought of evolution as anything other than a theory. He hoped that someday it would be proven by the fossil record, but did not live to see that, nor have we. 1925, in the famous Scopes monkey trial, this theory made its way through litigation into the classrooms of America, and we all have seen the consequence over the last 77 years. Evolution not taught as a sincere theory of biologists, but rather, Mr. Speaker, taught as fact. And lest anyone listening in would doubt that, we can all see in our mind's eye that grade room classroom we all grew up in, with the linear depiction of evolution just above the chalkboard. There's the little monkey crawling on the grass. There's the Neanderthal with his knuckles dragging, and then there's Mel Gibson standing in all of his glory. It is what we have been taught, that man proceeded and evolved along linear lines. But now comes a new find by paleontologists in the newspapers all across America. A new study in Nature magazine. 6 to 7 million-year-old skull has been unearthed, the Torme skull, and it suggests that human evolution was actually, according to a new theory, human evolution was taking place, and I'm quoting now, all across Africa and on the earth, and the earth was once truly, and I quote, a planet of the apes, on which nature was experimenting with many human-like creatures. Paleontologists are excited about this, Mr. Speaker, but no one's pointing out that the textbooks, I guess, will need to be changed, because the old theory of evolution, taught for 77 years in the classrooms of America as fact, is suddenly replaced by a new theory, or I hasten to add, I'm sure we'll be told, a new fact. Well, the truth is, it always was a theory, Mr. Speaker. And now that we've recognized evolution as a theory, I would simply and humbly ask, can we teach it as such? And can we also consider teaching other theories of the origin of species, like the theory that was believed in by every signer of the Declaration of Independence? Every signer of the Declaration of Independence believed that men and women were created and were endowed by that same Creator with certain unalienable rights. The Bible tells us that God created man in His own image, male and female, He created them. And I believe that, Mr. Speaker. I believe that God created the known universe, the earth and everything in it, including man. And I also believe that someday scientists will come to see that only the theory of intelligent design provides even a remotely rational explanation for the known universe. But until that day comes, and I have no fear of science, I believe that the more we study the science, the more the truths of faith will become apparent. I just would humbly ask, as new theories of evolution find their ways into the newspapers and into the textbooks, let us demand that educators around America teach evolution not as fact, but as theory, and an interesting theory to boot. But let's also bring into the minds of all of our children all of the theories about the unknowable, that some bright day in the future, through science and perhaps through faith, we will find the truth of from whence we come. And I yield back.
Christine, stop here and let's start the session. Sorry for delay.
I think Mike Pence is living proof against intelligent design.
Actually, he comes from the state of Indiana. The legislature of Indiana in 1894 passed a law that declared the value of pi to be 3.2 and said they will patent it so that the state of Indiana can earn revenues from it. It's a famous Indiana Act, and Mike Pence has had the benefit of education on that.
Wasn't that because someone had figured out how to square a circle? And I think that if you could square a circle, you would get 3.2. That's what it was.
Yes,
I remember.
exactly.
And someone should remind him that it's only a theory that the sun will rise tomorrow.
Let me stop it here, and we have to pass this session to the next session here.